The objective of this lab is to determine the mass of a theoretical black hole using Newton's universal law of gravitation and the momentum principle. The fundamental principles utilized in this lab are shown here. As you can see, once we have the mass of the star, distance from the black hole, and gravitational constant, the only unknowns are the mass of the black hole and the force of gravity. For the sake of this experiment, we are making the assumption that the only acting force is a gravitational force, meaning this value will also be the net force acting in the perpendicular direction. Therefore, by the momentum principle, we can calculate F net through calculating the momentum. Here is Newton's universal law of gravitation rearranged to find the mass of the black hole. This is what I will use in the final calculation in my Python code. Here is my Python code. First, I insert the given data, the mass of the star, position of black hole, and gravitational constant. I set my delta t equal to 1 day in seconds and set my initial t to 0. Then, I import the star's position data for use in my code. Here is my calculation loop. I use the formula for momentum. Momentum is equal to mass times velocity to find the initial and final momentum. From here, I am able to find the change of momentum, and through the momentum principle, F nets and its parallel and perpendicular components. In my final calculation to find the mass of the black hole, I use the rearranged law of universal gravitation. Here is what my code looks like when run. While it does not finish a full rotation, the physics can still be observed. The yellow arrow represents F net perpendicular, the black arrow represents F net parallel, the blue arrow represents momentum, and the black dot represents the black hole. Here, my code prints off the value it found through iteration with respect to time. You can also see it found the mass of the black hole. Now, it is important to note that even though the vector components of F net and the change in momentum are the same numbers, the two are not one and the same phenomenon. It is better to think of the change in momentum as caused by the net force. Now, what if this black hole was removed and a new one was put in its same position? Would we be able to calculate the mass of the new black hole? Well, since a new black hole is in the same location and the star's position data is unchanged, the answer is no. New data on the star's trajectory is necessary. Also, here is another look at the mass of the black hole calculation. As you can see, the magnitude of the net force in the star's position data should be updated to find the mass of the new black hole.